Hello everyone, this is Tejas Raj from Sri Venkateshwara College of Engineering from the course of Data Science, and I am here to teach about what is vector calculus. In the lower classes we have learned what is vectors, what is integrations, what is differentiation, which is come under calculus. So together combined we are talking about vector calculus. So let's go on. So in vector calculus we come under a journey through the captivating realm of a vector calculus, a powerful mathematical discipline that unlocks the secret of the multidimensional world around us, discover the integrate relationships between fields, gradients, and the elegant properties of the vectors operations. So in this, we are going to learn about the vector calculus and the elegant of all the properties of vector calculus and the gradients and what are the things will go on. So let's move on. So before moving on to vector calculus, first we need to understand what are the basics. So it comes of two types, which is scalar and vector. What is scalar? Scalar means speed which gives only the magnitude, not the directions. So what is vector? Vector comes under velocity. Velocity means the direction is also included, which we know that I cap, j cap, and k cap. So moving on, vectors are the mathematical entities that have both magnitude and directions. They are used to represent physical quantities like force, velocity, and accelerations. Then we comes under vector fields. So vector fields assign a vector to every point in space. They are used to model phenomena like gravitation fields, electric field, and fluid flow. Then we come under vector algebra. Vector algebra includes operations like addition, subtraction, scalar, multiplication, and dot cross products, which we know which is matrix also. These allows for the manipulation and combination of vectors. So let's move on. Now we are going to learn what is scalar and vector functions. What are the functions of scalar and the vectors? So scalar functions assign a single real number to each point in space, while vectors function assign a vector, a quantity with both magnitudes and direction to each point. Scalar functions can represent things like temperature or pressure, while vector function can represent fields like velocity or electric fields. Scalars and vector functions are fundamental building blocks in vector calculus, allowing for the mathematical description of various physical phenomena. Understanding the properties and behavior of these functions types is crucial for applying vector calculus techniques to solve real world problems. So now first we need to understand what is a point is given over here, like each point in space. For example, when I take this box on this, I'm landing on my ant. It doesn't have any value to this. So it creates an x-axis, y-axis, and z-axis as a 3D model. Then suppose if I give a force to this, it is going to create a force which having a direction of x-axis. As you can see, it is creating a x-axis. If I put upward, it has a upward direction of y-axis. If I drop it, due to gravity it is coming down, but it has a direction of downwards. So this is what a space as a thing or a vector which represents the things. So due to this, a vector calculus is a real world problems to solve. So let's move. Now we are coming to differentiation of vector fields. So partial derivatives, gradient of a scalar field, Jacobian matrix. So what is partial derivatives? Calculating the rate of change of a vector field's components with respect to individual variables, revealing the local behavior of the field. And gradient of the scalar field, finding the vector field whose components are the partial derivatives of scalar field, indicating the direction of the greatest increase. Then Jacobian matrix, organizing the partial derivatives of vector fields into the matrix, enabling the analysis of the field's local properties and transformations. Let's move on. Now we are moving to the gradient and the divergence and the curl, which is the main topic of vector calculus. So what is gradient? The gradient of the scalar field is a vector field that points in the direction of the greatest rate of change of the scalar field. It represents the steepness and the direction of the maximum increase of the function. And what is divergence? The divergence of the vector field measures the density of the outward flux of a vector field from an infinitesimal volume around a given point. It describes how the field is spreading out from or converging into that point. And what is curl? The curl of the vector field is a vector field that describes the infinitesimal rotation of the vector field around a given point. It measures the circulation density of the vector field. And also the importance of this is geometric interpretation. which means gradient, divergence and curl provides geometric insights into the behavior of vector, then enabling into the deeper understanding of physical phenomenon in fields like electromagnetism, fluid dynamics and general relativity. So let's move on. Moving on to line integral and path independence. So line integral measures the work done by a vector field along a specified path. These integrals can be used to determine if a vector field is conservative, meaning the work done is independent of the path taken between the 2 points. Path independence is a key property of conservative vector fields, allowing the use of simpler calculations to determine the potential functions and evaluate the integrals. So let's move on. Now we are coming to what is surface integral and flux. So defining surface integrals measures the amount of a vector field passing through a given surface. They are a crucial tool in vectors calculus for analyzing the flow or flux of the field over a 3D region. Then calculating flux, the flux of a vector field F through a surface S is a surface integral of the dot product of F and the unit normal vector to the surface. This quantity is the total outward flow from the surface. Then connecting integrals. Surface integrals are linked to line integrals through powerful theorems like Green's stokes and the divergence theorem. These provide elegant ways to compute surface integral using simpler line integrals. So let's move on. Now we are moving on to the Green-Stokes and divergence theorem. So what is Green theorems? This powerful theorem relates the line integral of the vector field around a closed curve to the double integral of the curl of the field over the region enclosed by the curve. Then in Stokes theorem connects the curl of the vector field to the line integral of the field around a surface boundary, allowing the calculation of 3D integrals with 2D informations. Then divergence theorem, also known as Gauss theorem, this fundamental results the flux of the vector field through a closed surface to the volume integral of the divergence of the field inside the surface. So now we are coming under what is applications of vector calculus. So there is of three types, which is electromagnetism, fluid dynamics and gravitation fields. So what is electromagnetism? Modeling electric and magnetic fields, analyzing of patterns and pressures of in fluid dynamics, and gravitation fields describing forces and potentials of gravity. So why do we use vector calculus? To find the electromagnetism, to find the gravitation field. Whenever we want to find a gravitation field, we come across the vector calculus. So that is why the vector calculus is very useful. And yeah, to this image, there are types of magnets, which is of horseshoe magnet and bar magnet. So as you can see, the lines, these are the imaginary lines, but experimentally it is proved that the lines has been formed in this way. And as we know, North Pole and South Pole get attracts and same pole will repel. Now we are talking about Newton's universal law of gravitation, which means the moon's gravitation field is causing the earth to accelerate towards the moon. Also in the same way, the earth's gravitation field is causing the moon to accelerate towards the earth. So let's move on. Here comes the conclusion of vector calculus. As you can see in the image, it tells that del phi, which means the gradient, is equal to dou f by dou xi plus dou f by dou yj, which is a formula of gradient. So here comes the conclusion of vector calculus. Thank you.